Well, hello. I'm Mr. Monty, geometry teacher at Lewis and Clark High School. Welcome back to lesson 17. Now, the last 3 lessons, we reviewed all our properties of quadrilaterals, slopes of lines, distance of lines, trying to get ready to actually do a proof where we're given a strange shape, we're told some items about that shape, and then we have to actually prove something. Now, proofs, usually in some sort of a T-column chart or a flow chart, where we go in a series of steps to try to finally prove whatever it is they ask. So let's take a look at this shape right here. Some sort of a rectangular shape, got a couple of diagonals at this point J. So let's see what the given is. EFGH is indeed a rectangle. EFGH is a rectangle. J, this point J, is a midpoint of EH. Midpoint. Remember what midpoint is? Break it in half, divide it in half. Good. We finally want to prove that triangle FJG, FJG is isosceles. The first thing I like to do is mark all the given. During the EOC, get yourself some highlighters, some colored pencils, mark this stuff. Once you get it all marked on the given, I think it makes it easier to see how to get from the given to the proof. So the first thing we'll do, EFGH is a rectangle. If you remember back a couple lessons, all the characteristics of a rectangle. Let's just draw a little rectangle here. 90 degrees. All 4 corners are 90 degrees. The opposite sides are congruent. Rectangle. So we've got our 90 degrees. Opposite sides are congruent. J is a midpoint. J is a midpoint. Let's just mark that right on our original shape. That means EJ is equal to JH. Okay? Isosceles triangle. Let's draw an isosceles triangle. Make sure we remember what that is. Isosceles triangle where 2 legs are congruent. So FJG, we need to prove that those 2 legs are indeed congruent. We want to show that this is equal to that. Actually, we could actually mark the opposite sides congruent here, couldn't we? You starting to see how we could get from the original rectangle to the isosceles? Let's mark the right angles. So we started with a rectangle. How can we show that this triangle right here is congruent to that triangle? Can you guys see it? Side, angle, side. Side, angle, side. If we can show that these 2 triangles are indeed congruent, then we can come back with one more statement and say that the CPCTC, the corresponding parts of congruent triangles are congruent. That shows that FG is equal to JG. And then we would finally have our proof. Since these 2 are equal to each other, it is indeed an isosceles triangle. Let's write this up. Put our T-chart in here. We have our statement. And then our reason. So the first thing we had, EFGH is a rectangle, and that was given. Since that's true, let's get our red lines done. Our opposite sides, EF, GH. EF is congruent to GH in a rectangle. Opposite sides are congruent. J is that midpoint. J is the midpoint of EH. That's given. From there, EJ is congruent to JH. Definition of midpoint. Oh, you want to do the right angles. Good job. Our right angles here, you do that in red. The right angle. So we'll go FEJ is congruent GHJ, and again, definition, a rectangle, all angles are 90 degrees. So, let's mark that. Side, angle, side. So we can actually say FEJ is congruent to GHJ, side, angle, side. Because of that, the CPCTC, corresponding parts of congruent triangles, are congruent. FJ is congruent to GJ because of the corresponding parts of congruent triangles are congruent. Once we show that these were indeed congruent, then we can say that. Finally, triangle FJG is isosceles, and we can say that because two legs are congruent. So the first thing I think we should do on these proofs is always get ourselves a roadmap. How can we go from the given, mark your given, to what we're trying to prove? Build a roadmap off to the side, then start to write it up. If you get confused and you don't remember some of these specific vocabulary words, write it out in sentence form what you're trying to show. We'll see you next time for lesson 18.